All right, it's 2:45, so before anybody else walks in and fills this place up, I guess I'll get started. This is my talk called Decoding Codable. You are all intentionally here, apparently, which is a little nerve-wracking, but awesome. The fish are up there because at work we always joke around that it's Codable, because we're easily amused. So I can no longer see Codable without thinking Codable and then fish. So there you go. I'll give you a brief rundown about what we'll be covering today. I will be looking at what, just a reminder to those of us who, did not develop more than a year ago, what JSON parsing looked like prior to Swift 4, prior to the introduction of Codable. What it looks like now, more importantly, with Codable, especially for those of us who may be stuck in legacy code and don't haven't had a chance to use it. What does it look like? What is it doing for us? And also, sort of the most important part, ways to deal with less than perfect JSON, because we all deal with JSON and it's never perfect, right? Things I won't be doing, it's not an exhaustive look at Codable by any means. This is just my way of explaining things the way I understand it, and that's how, that's how I function, right? I'm from a non-traditional background. I don't have a lengthy tech background, so I kind of put stuff in my real-world terms, and hopefully that helps connect this concept with some of you, but it's not going to be a deep dive under the hood. And it's also not going to be a step-by-step implementation guide. There will be code snippets, of course, and I'll talk you through some stuff, but it is not like a how-to. There will be no song and dance number, especially now that I have a broken leg. So, sorry about that. And forgive me for I'm used to pacing, and I can't really pace right now, so I'm kind of going to be like awkwardly swaying. It's the best I got. All right, so briefly about me, who I am standing in front of you. My name's Ellen. I'm an iOS developer at Detroit Labs, which is, in fact, in Detroit. Funny enough, I get that question quite a lot. We're a services company. We also have like a contracting component we call Onsite. We're always hiring. We are hiring iOS developers, so if you have any questions about that, feel free to hit me up anytime on Slack or after the talk. I'd be happy to talk to you about it. You can reach me on Twitter at L4Ellen. I don't tweet a whole lot. It's usually my beer habits from Untapped. And in the soccer season for our Detroit team, it's all soccer. But I do tweet when I'm at conferences. Other than that, I don't know, follow me for soccer and beer or whatever. But you can reach me on there. If you have a question after this talk or during it, feel free to hit me up on there. Little personal information. I travel in my free time, usually in search of new beers, which is why I'm very happy to be in Denver. Play hockey, but that might be over now. And if you can't see, I have a giant boot on my foot. And I like to hang out with my cats. So that's me when I'm not in front of a computer, or me when I'm riding a camel into the Sahara. Great. Now that you're all enthralled, you know me, let's get started. So, I know the font is tiny. That's, at least for these slides, that's not what's important, okay? This is sort of what we were, or how we were dealing with JSON prior to Codable being introduced, or how we're doing it now, right? And there's more than one way to skin a cat, that's for sure. So this is just an example of how we were parsing JSON just for comparison purposes. So we'd create a struct. For this example, we're making some imaginary weather app, picture your favorite weather API, and we're gonna care about the chance of rain, the temp, and some details, is it foggy or whatever. We gotta make this a init method that's gonna take in the JSON and assign our values to our properties. Okay, makes sense, we've seen this before. Then, for the actual parsing, we're gonna grab our JSON and make it into that dictionary that we can then pass into our init and get our object. pretty straightforward. This is not groundbreaking. So then, okay, we've got to map everything. We wait a second. Temperature's coming back, and it's got two values. It's got temperature, or it's got Fahrenheit and Celsius. Okay, so let's, I don't know, why not? We'll make it a tuple for now. We got the properties going in there, but that's another thing we have to dig down deep into the JSON to get, another thing to handle. Okay, we're getting a little longer, but okay, now we're going to make it so we can actually send a weather report back up. I use dark sky. It's actually nice because in Michigan the weather's never what it says. Dark sky is fairly accurate actually, but it'll be this weird thing where it's raining like right here and not here. So if I'm there, I report the rain. So okay, we're going to send the rain back up, the report. So we need to encode it. All right, this is kind of getting lengthy. So now this whole thing, just to a 3-value, a 3-property weather struct to encode, decode, get those Fahrenheit and Celsius, we're up to that. Again, that's why I said font size is not important. So enter Swift 4, and our buddy Codable, our knight in shining armor are here. And for those in the back, this is just purely comparison purposes. Now our decode method is that, and the important thing is one line there, right? So we took all that junk, all that init is gone, all the assigning of the keys, so temperature equals temperature and details equals details, all of that is gone. We have one line. All you have to do in Codable, and what is really cool about it, is you just say, hey, I'm going to give you some JSON. Give me this object back. Give me this current weather object back from that JSON I'm giving you. And Swift does the rest, which is really cool. There's some asterisks here. We'll get into that, of course. And encoding, whereas before we had to add a bunch of stuff, now we've got, pretty simply, pretty much the same thing. We just say, instead of making a decoder, we have an encoder. Encode it for me, send it up. Like, encode my object, send it out. Which is pretty cool. So the magic that's kind of going on here, as I break it down, is that initialization method that we had, where we had to say which values equals what. That's handled for you by Swift, which is cool. CodingKeys, where we're saying, hey, in this dictionary, temperature equals my temperature value. Swift is smart enough, it synthesizes that for you and takes care of it. I find this way cleaner and easier to read. And as the software nerd I am, and most of us all are, the cool thing is it takes weakly typed JSON and turns it into strongly typed Swift, because I love my strongly typed languages. So that to me is that's the actual magic that's happening, right? So that's fantastic, very straightforward. None of us have probably actually seen an API that gives us JSON that clean and simple with that little issue. So what if we want to actually say, okay, we're going to get the details back, and it's going to be, I don't know, there's going to be 5 different types, right? Or 4 different types. How do you actually make something codable? You just put Codable, have it conform to the Codable protocol, as you can see up there. So I say current weather, Codable. As long as each of the properties inside of that struct also conform to Codable, you're golden. So that includes all your primitive types. You got strings, ints. What if we want something, like I said, okay, we could get details as a string, but we know it's only going to be 4 different types in this case. Think of your favorite example of when you'd want to use an enum coming back from your API. That enum, to make that codable, I've got all these custom types I want in here, all I have to do is make that enum itself codable. So I just add the Codable protocol to the end of that enum, and it takes care of it for me. I don't have to go and write assignment saying, fair is equal to string fair that comes back, or anything like that. It'll handle it for you, which is pretty cool. So again, because Swift is taking care of synthesizing your coding keys for you, it is saying this what I was showing you works if your temperature is coming back listed as temperature, right? That's a rare occasion. Maybe we luck out and get half of our values that way, but a lot of times they're different. Maybe they're even just, maybe it's just snake case or something's different, but the way we want to name our properties in our app that we're building don't always match what's coming back in the JSON. So enter custom coding keys. So in this case, details is coming back as weather description. To make this work, you make an enum, call it CodingKeys, type string, and coding key on the end there. And then the one downside, you do have to list them all out. But if you're not making any changes, you can do it simply in one line, comma separated values. So all of your properties that are coming back that match, you don't need to do any changes to. You just put those in one case all the way across, like I've done here with case, chance of rain, and temperature. And then details, that's the one where I need to change. That's where I can make my assignment and say details equals weather description. That's it. I don't have to then go and do any more assigning. It automatically knows to use those coding keys when decoding my object, because it's inside of my struct I'm trying to decode. So that's great, but this is still relatively simple JSON, right? I've had the luxury for the past year to work on a project where my team is actually in charge of the back end, or in our case, it's the back end for front end that we're interfacing with, and they're in charge of all the APIs. So I actually get somewhat of a say in what I'm getting back, which is kind of a rare treat. At the same time, that's me arguing with my coworkers about whether or not, yeah, no, you should just make it easier for me, or if I should try to make their job easier, right? So there's still things, even though I have this control, and most of us don't. Before this, I did not have any control over that. I was just stuck with the JSON I was getting. And there's still times where I want to make it easier on my coworkers, right? So we can get into actually manually encoding and decoding. And this is where, being truthful and having worked with it for a year, this is where you start to run into, is it really worth it versus what you're used to and what you've been doing? And I'm truthfully not here to pass judgment on that. I'm just going to kind of talk you through how it's done, and you'll know in your situation whether or not it's worth it. Just know that it's available. So the first thing that you need to know about if you're going to create manual or encoders or decoders is containers. And the way I think of containers is like a box that you're going to put stuff in. There's 3 types. Keyed container, just think of it like a dictionary. Unkeyed container is ordered values, so think of an array that keeps its order. Or a single value container, which is just the thing, just the value. It does not actually contain an element inside it. It is just whatever it gives you, and that's it. They are mutable. They have to be, because we need to write to them. And you need to be able to specify the keys for them. So why would we want to do this? What are the situations where we'd want to do this? For when we would want to do any sort of manipulation of the data sort of during the parsing. Because the idea of this is that when we're done with parsing, we get our object exactly how we want it. So you don't have to manipulate, you don't have to change that date, unless of course there's 5 different dates formats you need for different reasons down the road. But you want that object coming out of that parsing just the way you want it. And containers allow us to do that work, that manipulation. So on the other side of the networking, your object is just what you want. Which, for example, here there's actually a neat method built in to decode like ISO 860 dates for you. So you say, it's the last line up here, so date in my container, which has all my values in it, try to decode my date from this format and give me my new date. Another option would be if you wanted to do something like if all my temperatures are coming back with decimals, right? My user doesn't care about that. They just want to know, they don't care if it's 68.3 or 68.2, they just, 68 is good enough, or we're going to round up. Okay, if I wanted to round everything, I could get my temperatures and then apply the round operator or function on it to round them all up inside of this. So then when on the other side, I get my object, the numbers are already taken care of. I don't have to worry about manipulating them in a way that I want. Another thing containers allow us to do is have nested containers. So if I want to add, say, the city to my weather, right? I'm going to have the city on my app. I don't have to, if it comes back as like the full address, like the full location with longitude and latitude, and I don't care about that, I don't need to have all that, right? I just want the city. I only need to have the properties I care about coming back from the JSON. But say city, like I said, is buried underneath location in the JSON. I have my coding keys for my top level JSON, as you can see. So I have chance of rain, temperature, date, address is one that's added, right? I have this address object coming back. Now if I need to get inside that, I can add another set of coding keys, another enum. And in this case, I just add city to that, because that's all I care about. If I wanted state, I could do city and state. And with the address keys, I add coding key. Then, there is one more step you gotta do, which is kind of frustrating. So again, I'm putting it all out there on my experience. You do have to decode every property now. So before this would have been handled for you. But if you're going to do custom, you have to do each one, even if you're only manipulating one, that's where some of the annoyance comes in. But the neat thing is all I had to do to get the city was call out location values. I'm going to break it down here so you see just the lines that we care about right now. So I get location values. I say, okay, location values, that's going to be the item for the key address. And I want you to use address keys. It's a type of that, right? It's going to use that to decode it. And then I can go for city is just, okay, cool, now use my location values and just give me the item for city. So it's 2 lines to get in there, in deep nested into the containers, which is pretty nice. Then you can, of course, manipulate it any way you want. Another common occurrence is, okay, great, what if your root element is actually an array of things? All you have to do is put your element, so current weather, if I had like a bunch of forecasts in a row, right? Just put that in an array, everything else takes care of itself. So you're going to get an array of those objects automatically. I've been talking all about Codable, but one thing I want to break down for you is that it's actually a type alias for Encodable and Decodable, so it's the 2 things together. So there is this added bit of safety that you can get if you want to say, you know something's only ever going to be encoded, or you know something's only ever going to be decoded, then just have them conform to encodable or decodable. You don't need to make it conform to codable. That can add that bit of safety for you, which is a nice little thing. But they all work the same. The biggest difference being if you're encoding, you need an encoder. If you're decoding, you need a decoder. Outside of that, all the functionality is the same. And so nothing else changes. That's why I've just been referring to it as Codable the entire time. But just so you know, it's 2 separate things. One cool addition that has come along, and that I'm hoping to see more growth and change as Swift continues to evolve, is this keyDecodingStrategy. So an example I gave earlier that we commonly see, say like maybe the only difference between our values, names, and what we're getting from the JSON is that it's snake case, right? And that's frustrating to have to just say, yeah, okay, temperature, or like city temperature equals city underscore temperature for everything. That would be frustrating. Cool thing that they've given us in the box is convert from snake case. So you can assign your decoder a key decoding strategy and tell it that it's, in this case, convert from snake case, and it does that automatically for you. So if the only difference is that you need to go from snake case to camel case, use this one line when you're declaring your decoder. Just give it its key decoding strategy, and it'll take care of that change for you, which is pretty cool. I'm hoping to see that grow a bit more, maybe even like kebab case, or if there's other situations, all caps, or anything else to help sort of normalize. I would love to see that continue to grow. There is an option that I haven't personally played with, but I know exists, and that you can create a custom decoding strategy. So more legwork on your end, but if you know that all your data is going to need to go through the same manipulation, all of your property values or all your values have the same maybe naming convention that you know needs to always be changed, you can then create your own and apply it. So that way that is taken care of for you as well. Little bit of overhead, but if you're dealing with a ton of data that you know the change is always the same, it might be worth your time to do that. And that's a cool thing that was made available. And full disclosure, that snippet there is straight from the Apple Docs. I haven't played with it, so if anybody has experience with it, I'd love to talk to you about it. That's not something I've delved into yet. A couple things that I haven't touched on yet and won't go too deeply into, but just want to make sure that you're aware of, is I've been talking about Codable as being used with JSON. It can also, right out of the box, be used with plists. And there is also the ability to make a completely custom encoder if you want to do that. So you could encode and decode and use Codable with like XML, for example. You'd have to do the legwork for that, but if that is something you want to be able to use Codable for, the ability is there. The date decoding strategy, I'd like to see that hopefully get built on more down the road, maybe Swift 5. Right now, I mentioned ISO 8601, but there's also milliseconds since 1970, and that's it, though. So it's kind of limited right now. And I'd like to see that continue to grow, because as we all know, dates are a pain. There are a lot of resources. I've linked to a couple of them that I'll put up at the end for handling dates. I didn't want to stand up here because it would probably take like 2 hours to walk through all the options you have with dates. That's not what I'm into. So there are also a lot of resources out there for handling floats. If you're not aware that could be an issue if JSON returns like not a number or infinity. So how to work with that, there's a lot of resources that delve into that. I did not touch on utilizing Codable with other frameworks like RxSwift. I'd be happy to talk about that after, or if you got questions later. I've been primarily working with, for last year, we've been using Codable along with RxSwift and Moya. So that's where a lot of my experience is using it. As I'm wrapping up, I do want to take time after, in just a moment here, to take questions or comments, because I've already been talking to a few people who have had different experiences running into issues, especially if you have structs or, like enums with associated values, having issues with that. And I'm happy to try to answer any questions you have as well. I have a repo for my talks, but will post them in the Slack channel as well. You can always reach out to me on Twitter. So you'll be able to get these links instead of having to like type them in. But these 4 articles in particular, I used a lot to get my knowledge to create this talk, and they have tons more information in them as well. But that is it for now. I would love to take any questions or comments you have. Yeah.
Really basic, I know you said Codable or Codable. What happens in the case where you're expecting an object with 4 keys, and one of the keys is misspelled in the case, or it's not there? What happens?
That's a great question. So his question is like, what happens if you're saying if the key is misspelled on the JSON, like you didn't misspell it?
Yeah.
I guess either way, if there's a mismatch, at least in my experience, this is where doing error handling is really helpful. As I find every time my app fails to parse my JSON and it just says this doesn't exist. So it fails, it won't parse it for you. And then whatever, however you handle that error is what you'll get at the end, if that makes sense. But you just don't get it. And if it's not nillable, you won't get the object at all.
Okay, but if it's nullable, you'll get what you get.
Yes.
Okay.
Yeah, for sure. So yeah, using like optional properties, if that's how you want to do it or whatever. But if everything's required, that is an important thing to know. If everything's required in your object and there is even just a mismatch, your whole object will fail to parse. And you pretty much just get like a console log saying this like value, like ID, doesn't exist, could not parse it. Which in my case, when I'm trying to like make 4 API calls and get a bunch of stuff down, I'm like, which one of these things with ID? Handle your errors. It's good learning. Yeah, in the back.
So when you were talking about coding keys, do they have to be exhaustive to what you're using? Do you know this is just going to ignore the ones that you don't want?
Oh, for the payload, they don't have to be exhaustive to the JSON. They just have to be exhaustive to the struct. That's a great question. So he's asking if your coding keys need to be exhaustive just to the struct, for all the properties that are in your struct. They do not need to be exhaustive for what is coming back in the JSON. A nice thing is that all you have to deal with in what you're writing is all you care about. You never really have to handle anything you don't care about unless, say, it's like one of those nested values where you need to get inside of location to get down to city. Other than that, you don't need to deal with anything in the app that you don't care about and don't plan to use. Yeah.
For the location example, could you make another location codable type and then only have city as a key in there?
Yeah.
And so that way you don't have to for kind of common cases like that.
Yeah, common cases like that, absolutely. That would probably be a much better way to handle that specific thing. Yeah. But if you, the thing, the technique I use the most is basically creating custom types and making sure all of my, every single one of my models that pertain to the JSON at all are all conform to Codable. And then there's the neat thing that's coming down with Encodable too. And I wanted to touch on that, but this talk was supposed to be 2 days from now, so I was going to add more. And I found out like 2 hours ago that I'm doing it now. But I don't know if you know, but there's like adding Encodable onto your objects. That's going to start to take care of all the synthesizing for you, so you don't have to say like right-hand side equals left-hand side for each of your properties inside like your struct. So inside of my weather, I don't even know what I called it now, but my weather struct, if I wanted to compare two weather objects for some reason, you can just say that it conforms to Encodable, and you don't have to no longer compare each left-hand and right-hand side. Anyways, it's a cool thing. I'm really excited about it. It's going to save me a lot of work. All right. Any other? Yeah, sure.
Sorry.
No, it's okay.
So is it safe to assume that if they have data that is coming back, let's say it's multiple like nests, that you have to do manual decoding, or is Codable really that smart of
Yeah, you might not have to do manual decoding. It kind of depends, right? If you can, sort of like he was saying, if you can break down those nested objects into like your custom types that you can then get to, it can handle it on its own. But typically, if it won't map correctly that way for you, like if that doesn't make sense, then yeah, you're going to have to do the manual decoding. Yeah.
Enums with associated values work at all here? Like you say, I have 4 candidate types, and this field will be one of those 4. That seems like it would be hard to.
Yeah, it doesn't. That's somebody brought that up actually early in an earlier session, and I was like, "Oh, I really want to know if you figured out a way to do that." But yeah, that's one spot where I've started to see it getting tricky. There's ways around it, but it's not ideal. That's for sure. All right, I want to thank everybody for coming. I really appreciate you being here, and I hope you have a great rest of 360.